My name is Kiranpreet, and today I will be sharing with you our new study, which was a field trial in collaboration with Skretting, focusing or highlighting the benefits of including krill meal for better growth and better survival in the Atlantic salmon smolts after their seawater transfer. But before going into the study details, let's have a brief look at the global challenge of food insecurity. We all know that we are a growing population and more food is needed for the generations to come. And for that, we need to shift from our over-reliance on the land-based resources and have to have more seafood on our platter. And if we look at the wild fishery stocks, unfortunately, they are overexploited, as you see on the figure on the right top. Majority of those wild fisheries, they have either reached their sustainable limits or have even crossed those limits. So in order to have more seafood on our platter in a sustainable way, we need to expand aquaculture. And for the sustainable growth of aquaculture, we need more sustainable feeds, as these are the bottleneck in the aquaculture growth. Why? Because these are essential part of the production. Every fish needs good quality nutrients for its growth and welfare. But at the same time, it is the most expensive part of the production. It is also well recognized that there is a huge gap of feed in the years to come for the aquaculture growth. For example, in this figure, there is an estimated feed gap of almost 50% in the salmon aquaculture production in Norway. That is estimated by NCE Seafood Innovation in comparison to the current volumes. And this is after including some of the novel ingredients. So this is a huge gap. And the industry needs many more novel ingredients and alternatives to fill this gap. As is nicely mentioned by Helen, we need more raw materials in our basket. And there are raw materials or novel ingredients such as insect meal, single-cell proteins, microalgae, and now the new fish meal that have the growth potential. But there are hurdles of, for example, cost of production. There are hurdles of customer acceptance. There are hurdles of volumes that are needed. And also, if we look at the dramatic change in the feed formulation of salmon, for example, in Norway, from being predominantly marine-based in the 90s and today's mainly plant-based feed formulation, we should not forget the basic nature of salmon, that it is a carnivorous fish. And some of the marine ingredients, they are needed, as is nicely mentioned by Helen and Ola, that salmon needs, or any carnivorous fish, they need some of the marine ingredients. Why? Because some of the nutrients, they are derived from marine ingredients. As it's nicely showcased recently by in Nufima's recent research. For example, in this graph at the right top, you see the percentage of non-protein nitrogen components in the salmon feeds. So it has higher percentage in the starter and the small feeds, but that percentage dramatically drops in the seawater grower phase. Why? Because there is a dramatic decline in the inclusion of marine ingredients during that seawater phase. And these non-protein nitrogen components, even though they are labeled as non-essential part of the feed, they play an important role. And these non-protein nitrogen components, for example, free amino acids, short peptides, that's nicely mentioned by Helen, they act as biopeptides. Osmolytes such as TMAO, they increase the palatability of the feed. They also increase the digestibility of the feed. And they are helping the salmon during these stressful periods. For example, during osmotic stress salmon faces after the seawater transfer, or during the cold water conditions. Hence, it would be beneficial to have some inclusion of these functional marine ingredients in the salmon feeds during these critical phases. And one such functional marine ingredient could be Antarctic krill. it is a highly sustainable marine resource as it represents the largest single species biomass on Earth. It is a clean ingredient with no plastic contamination and negligible amounts of environmental toxins. It has high energy retention because it comes from the low trophic levels in the marine food chain. It has low carbon footprint and it has the highest rating in the MSC certification. The commercial krill harvesting is highly regulated and controlled. If we look at the total biomass in the Antarctic Ocean, as you see here in this figure, so the total biomass of krill in the Antarctic Ocean is around 500 million tons. But the commercial harvesting is allowed only in a small area in the Antarctic Ocean, where the krill biomass is around 63 million tons. And the commercial quota for harvesting is set at 1% of that biomass. And the actual harvesting is even lower, indicating that there are very highly, strictly regulated controlled conditions for these commercial fisheries. And because of these strict regulations, the krill biomass has been stable and healthy over the years, as is recently documented over a 19-year monitoring report from 2000 to 2019 is pretty stable and healthy, indicating that it is a sustainable biomass. In addition to being a sustainable resource, it is also rich in many nutrients. So in this figure, you see the typical values of nutrients that are present in the krill meal. On typical levels, it contains 25% fat, and it is rich in omega-3 fatty acids, mainly EPA and DHA. It is also rich in phospholipids, mainly phosphatidyl choline. It also contains micronutrients such as astaxanthin and choline. And on the typical levels, it contains 57% crude protein with a very good balance of essential and non-essential amino acids. It also contains vitamins and minerals, and it is a good source of non-protein nitrogen components, as I've mentioned in the previous slides, such as it's a good source of TMAO, it's a good source of short peptides, free amino acids, and nucleotides. There are more than 130 published articles showcasing the benefits of including krill meal in the Atlantic salmon diets. And these benefits include higher feed intake because it increases the palatability of the feed. And this higher feed intake leads to better growth of the fish. Inclusion of krill meal also enhances the organ health, for example, better heart health, better liver health, better intestinal health. And for the product quality, krill meal inclusion leads to better pigmentation of the fillet, reduced gaping, reduced melanosis, and better texture of the fillet. So this current field trial was kind of a validation of this vast documentation in the real-life scenario. And this was performed by Skretting under their R&D licenses that are issued by Norwegian Directorate of Fisheries. And it was performed during the seawater transfer. As we know, that seawater transfer is a very challenging and critical phase for salmon smolts because it causes osmotic stress, and it is also associated with reduced feed intake, so the fish is not eating properly. That negatively affects the health and welfare of the fish. And it is also associated with high mortalities. That leads to huge economical losses, as it's nicely documented in the recent Norwegian Fish Health Report with a record high number of mortalities in Atlantic salmon. And a significant percentage of those mortalities, they happen during their first few months of the transfer to seawater. So it would be beneficial to include functional, sustainable marine ingredients during these critical phases so that salmon can cope better with such stressful periods. And with this thought in mind, the current field trial was performed at a commercial salmon farm at the Harstad municipality that is operated by Salmar Farming. And the initial weight of the fish at the starting of this trial was 160 grams. The feeding period lasted for 116 days until the fish was around 1 kg. There were 10 net pens included in this trial, with 5 net pens that were fed on the commercial feed and another 5 net pens that were fed with 10% krill meal. I'll explain the feeds in the next slide. The feeding period was from end of May and going up to September, and the average temperature during that period was 10.2 degrees Celsius, ranging from 4.8 going up to 13.4 degrees. The fish were fed with automatic feeders, and the daily feeding was recorded in the fish stock, where the growth was estimated using the growth models and the data that was registered. There was also sea lice treatment for 9 days with slice feed in the mid of July during this trial. These were the experimental feeds. As I've mentioned, the 5 net pens, they were fed with commercial feed from Skretting called Spirit Supreme Plus. And the another 5 net pens, they were fed with 10% krill meal diet. In that table, you see the formulation of those 2 feeds. So they were isonutritious in terms of their proximate composition and other nutrients such as EPA, DHA, N3, N6 ratio, and so on. So in this table, you see the results after 116 days of feeding in the 5 net pens in the control group that were fed with commercial feed and 5 net pens that were eating 10% krill meal diet. So you see there was higher feed consumed in the 10% krill meal group, as shown by the average feed consumed here, and that led to better growth performance of the fish, as shown by a higher weight gain per group in the 10% krill meal group. In addition to higher feed intake and better growth, there was also reduced mortalities observed in the net pens where 10% krill meal fish, the feed was given. So putting those results into graphs, there was better growth performance, as you see here, in terms of the weight gain in the 10% krill meal group. So these circles and squares, they represent individual net pens. And in addition to better weight gain, there was also 22% reduced mortality that was observed in the 10% krill meal group. Then we also looked into the return of investment from these results using the Vitaya simulation tools. So the 10% krill meal group, which is shown by this orange line, had better forecasted growth and better forecasted biomass in comparison to the control group that is shown by this blue part or the blue line in that graph. And these better forecasted growth and better forecasted biomass in the krill group led to better estimated profit, as you see here, or in this graph on the forecasted bioeconomic, indicating clearly that the additional cost of adding krill meal in the feed, it pays off through a higher estimated profit that comes from better survival and better growth of the fish. And to summarize this study, so this is the first published report on a field trial that is conducted with krill meal in the Atlantic salmon smolts during their seawater transfer. There was 3% better feed intake, 4% better growth, and 22% reduced mortality that was observed with 10% krill meal diet in comparison to the control feed. So if you are interested in knowing more about this study, please click on the link that is mentioned here, and you will get the full text of this article for free. Thank you so much for your attention.
Thank you for a nice presentation. Any questions from the audience? There.
Thank you for a very nice presentation. I was just wondering, considering the feed intake, did you measure that accurately, or did you use the data in fish stock?
Yeah, as I've mentioned, this trial was conducted under the R&D licenses of Skretting. So in a field trial, it's not possible, because there were 200,000 fish in each net pen. So it was through the data that is entered in the fish stock database.
Okay, thank you.
I have a quick question here. Did you look at the fillet quality at the end of the trial?
Yes.
Yeah. Was there any differences between the treatments?
No. And then that fillet quality was on sampled fish.
Yeah.
And then I would say, like, if you sample 10 fish out of 100,000 fish, then you cannot be sure that it is a true representative. And that's kind of the limitation. When you have a field trial, you can't sample as many fish as you want to be sure about. Yeah. But we didn't see any differences. Yeah.
Another question.
Yes. Thank you for the presentation. I was wondering when you mentioned about the stock of the krill available and healthy maintenance, let's say. So is there potential for growth on the use of that krill that is harvested for aquaculture? Like, is everything used already from what is fished out, or can we actually use more for aquaculture? Or do we need to fish more to apply it to aquaculture purpose?
So the quota that is allowed for commercial harvesting is 1%. So far, that quota has not reached because of the weather conditions in the Antarctic, and the season is open. So to reach that maximum limit, yes, might be there would be more volumes. But then we should not compare krill meal as a commodity. There should be a clever use of the marine ingredients, as it was nicely mentioned by the early speakers as well. Like, there is a huge potential, but to use it in a clever way for the marine ingredients. But the volumes are there.
Okay, nice.
Okay, thanks.
Did you replace the krill meal?
There was 1/3 of replacement with the fish meal. So the high quality fish meal that was in the commercial feed, 15%, and it was only 5%. And the same goes for fish oil. There was reduction in the percentage of fish oil in the 10% krill meal diet.